Welcome. Welcome to the fourth problem in the DSA playlist. This problem titled as Merge Sorted Array. Let's try to understand what is a problem statement. You are given two sorted array, that is nums1 and nums2. Both are sorted, and another information given is that the nums1 sorted array contains m valid elements and n zeros. Basically these are placeholders. You will be understanding much clearly if I write an example. And nums2 will be having n elements. Let's see an example. So an example is 1 2 3 0 0 0, and the given information is m equal to 3. That is nothing but the number of valid elements. Even though the total length is 6, that means the n equal to 3 are zeros here, basically placeholders. And nums2 given as 2 5 6, and information associated with nums2 is n equal to 3. And what you are supposed to do is that you have to merge these two already sorted array into nums1, and that particular manipulation should be in such a way that the nums1 itself should be sorted. That means after doing certain operation, the output should be such that nums1 would be modified as 1 2 2 3 5 6, replacing all the 0. This would be the nums1. We have to do this thing, so we can write the output. Required output would be nums1 takes the form of 1 2. When it gets sorted, this 2 will be somewhere here, that is 2 3 5 6. So how can we do that? So there is a brute force method, also two pointer simpler experiment. We can see both the problems and we can evaluate the time and space complexity associated with the problem. So solution 1, I would say the solution. It is to first append these things in the place of zeros. Then sort the entire array. So let's try to code it. This is solution 1. Class solution 1, the method inside the class, merge. Let's write the argument by self, so that way we would understand the problem statement very better way. Self nums1 is already given as list of integer, and information associated with nums1 is m, which is also integer, and nums2, which is a list of integer, and n, which is an integer. And what is the return type? We are not going to return anything. We are just going to update the nums1 and going to keep as it is. So there is no return type associated with this method, so it is none. And how we are going to start? We are going to iterate nums2 and this will be taken and replaced in these particular locations. That's what we're going to do first step. So for I in range of n, nums 1 of m plus I, this m plus I would take us to this particular location. Then as I increases, it will take to this particular locations. That would be substituted by nums 2 of I. Doing so, these values will get append to the end portions where the zeros exist, but it is not sorted yet. So then at the end we are going to sort also. So that would be nums 1 dot sort. It's an inbuilt function, and we can, if required, we can write the sorting function also, but in this problem I'm just going to mention we are sorting using the inbuilt function. So what is the time and space complexity here? Let's try to address that. So you can see that there is an iteration of n times happen here, and there is sorting also happening here. Sorting happens in an array that has m plus n elements. So the time complexity would be initial an iteration of the order of n, and sorting on an array which has m plus n elements. So it will be m plus n log m plus n. If required, we can just optimize by removing this element. So it could be m plus n log m plus n. And the space complexity, since we are not using any extra arrays to store information or anything like that, it will be order of 1. So can we make it a better solution? And yes, we can see the second type of solution, that is solution 2 using pointers. So how we are going to solve this using pointer? Suppose this is nums 1 that has valid elements, say up to this point, and remaining are 0, and this is nums 2. We are going to keep a pointer here. Let the pointer be p1, another pointer here, let the pointer be p, another pointer here, let the pointer be p2, and we will start from these pointers until both of them get exhausted. And what we are going to do, we will compare the element at p1 and p2, and whichever is greater, that will be append to the p, and p will move to the adjacent location. If it was p2 is the one thing which adjusted there, then p2 has to move there. If suppose p1 was higher, then p1 would have taken this position, then p would have been moved here, and p1 would have been moved here, one location like this. And we will do until this nums 2 get exhausted, because we don't need to exhaust p1 because it's already sorted and it's already in the correct positions. So let's try to code this idea. I'm just going to copy the class and method definition from here to avoid repeatedness. Copied. Let me paste it here. To save space, I'm going to remove this particular example. That was not required, but let it be like that. and let's find out the pointers, that is P1, P2, P. P1 is nothing but m minus 1, P2 is n minus 1, and P is m plus n minus 1. And I'm going to iterate while P1 greater than or equal to 0 and P2 greater than or equal to 0. And then inside that thing I'm going to check if nums1 of P1 is greater than nums2 of P2. In that condition I am going to substitute nums1 of P with nums1 of P1, and followed by the P will goes one position down and P1 will also go one position down. So that would be P minus equal to 1, P1 minus equal to 1. If it's not that condition, if it was an else condition, then nums1 of P would have taken nums2 of P2, and then this P2 had reduced by 1, and obviously P would have reduced to 1. That would have happened. So that would be P minus equal to 1, P2 minus equal to 1. Even after doing, if still this array pointer does not exhausted, that has to be inserted into these locations. That has to also be checked. So we need some more space here. So for that I am just arranging a bit. Then it is while P2 greater than or equal to 0, nums1 of P should be substituted by nums2 of P2, and P minus equal to 1, P2 minus equal to 1. This is enough. This will alter or manipulate nums1 in a sorted fashion. And the question is, what is the time complexity? The time complexity is, here you are going to iterate to a maximum of, here in this array you are going to iterate to a maximum of n elements. Here it is like m elements, so it will be order of m plus n. And space complexity, we are not utilizing any extra space, that would be order of 1. So in comparison to the solution 1 discussed, this is slightly better, because solution 1 was mn log n plus 1. Here it is m plus n. So with that, this particular problem is solved and done. Thank you.